Alrighty, so now we're at the second part of our video, and what we're going to do is we're going to talk about how to find the x-intercepts of our vertex form. So our x-intercepts, they have a couple names, and those are solutions, roots, or zeros, and they're all the same exact thing. Fix that, zeros. So they're all the same exact thing. It's just there are x-intercepts on our vertex form, on our graph. So to kind of think about how we looked at our other graph, what we were doing was we were going along this line, or our y-axis. So what we're going to do now is go along our x-axis. So if I have a couple points here, that's a really poorly drawn line, but here I would have, say, -2, 0, -1, 0. Here I have +1, 0, and 2, 0. Now, the same thing as last time. There's a pattern here, and that pattern is that all of our y values, so like here, 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 and here, all of our y values are equal to 0. So what we're going to do to find our x-intercepts are we're going to plug 0 in for y and solve. Now, the solve portion here is very important. And we'll see that when we get to a problem. So when we get here, we're going to see that we have y equals, and then the rest of an equation. So when we plug in our 0, we're going to plug it into this y. So I'm going to have 0 equals x minus 3 squared minus 9. Now, the reason we say solve is because we have to solve for this x. So how are we going to do that? We're going to solve for x by getting x by itself. So how are we going to do that? So I like to get everything, I like to do the opposite of PEMDAS. So the first thing I'm going to do is add or subtract. And I have this -9 here, so I'm going to move it over. So what we do to one side, we do to the other. And that's going to give me 9 equals x minus 3 squared. So let's see, add or subtract, multiply, divide, exponents, parentheses. So we took care of the adding and subtracting. We added the 9 to both sides. So multiplying and dividing is only going to be a concern to us whenever we have a value for our a. So if we look here where our a would normally be, there's no number there. It's just an imaginary 1. So if we do the opposite, that would be dividing by 1. It doesn't change anything. So we don't have to worry about that. So multiplying, dividing, taken care of. So the next thing is we have to worry about our exponent. So that exponent is this 2 right here. So we have to do the opposite of the exponent. So the opposite of exponent is actually going to be using our square root. So what we're going to do is square root and square root that whole side. So square root of 9, pretty easy because 9 is a perfect square. And that's going to give me plus or minus 3. And then that's going to be equal to just x minus 3. Because this square right here and the square root are actually going to cancel each other out. And that's just going to leave me with x minus 3. So that takes care of the exponent. Now I just have to deal with what was left in the parentheses, which was that x minus 3. But if we look, I can't just move that 3 over because I have the plus or the minus. So what that's actually telling us is we have two equations here. So I have minus 3 equals x minus 3, and a positive 3 equals x minus 3. And then the last step is I'm just going to add 3. That's going to give me 0 equals x. Add 3. That's going to give me 6 equals x. So for my ordered pairs or my coordinates, I can write 0, 0, and oops, that was all messy. There we go. We write 6, 0. So that's how we find the x-intercepts. Just a little extra step because we have to actually solve. And once we do that square root, we're actually going to end up with 2 equations. So let's go ahead and do a practice problem. So I'm going to say y equals x minus 3 squared minus 16. So go ahead, pause the video for a second, and try and work that on yourself, and then we'll get going. Okay, so hopefully pause the video. Let's jump right into this. So we have to solve for our x-intercepts. So that means we're going to plug in 0 for our y. So I'm going to have 0 equals x minus 3 squared minus 16. So first step is I'm going to move this 16 over. And that's going to give me 16 equals x minus 3 squared. Now, after that, we have to deal with our exponent. So I'm going to do that by square rooting both sides. So, like we said in our practice problem, or in our example, the square and the square root are going to cancel. So that's going to give me x minus 3. And then square root of 16 is a perfect square, and that gives me 4. So it's going to be plus or minus 4. Now, because I have that plus or minus, I have to set this up as 2 equations. So I'm going to say 4 equals x minus 3, and negative 4 equals x minus 3. And then, last but not least, I'm going to add 3. That's going to give me 7 equals x. Add 3 here. That's going to give me negative 1 equals x. So my two coordinates are going to be, or my ordered pairs, are going to be 7, 0 and negative 1, 0. All right, cool. So we haven't done one where we have to use multiplication. So we're actually going to try that now. But go ahead and try this on your own first. And then we are going to, if you get stuck, come back and we'll work on it together. So here, hopefully you tried it out, maybe you got stuck, but this is what we're going to do. Same exact thing, we're going to plug in 0 for our y. That's going to be 0 equals 4 times x minus 2 squared minus 16. So, first thing I'm going to do, I'm going to add 16 to both sides. That's going to give me 16 equals 4 times x minus 2 squared. Now, what I want to do next is I want to deal with this 4, because if I start square rooting now, it could turn into a big mess, and I don't like messes. So what I'm going to do is I'm going to divide by 4 on both sides. That's going to give me 4 equals x minus 2 squared. And then now we can continue like we normally have been. And what we can do is we can do the square root. So that's going to cancel out. And square root of 4 is 2, so plus or minus 2 equals x minus 2. And then from here, we're going to write our two equations. 2 equals x minus 2, and negative 2 equals x minus 2. And then solve. So I'm going to add 2 to both sides here. It's going to give me 4 equals x plus 2. That's going to give me 0 equals x. So my coordinates, or my ordered pairs, would be 4, 0, and 0, 0. So that's how we find the x coordinate, or the x-intercepts for our vertex form equation.